Hello everyone, welcome back. So in this video we are going to see the LeetCode problem number. Give me 1 second. Yeah. So in this video we are going to understand this LeetCode problem number 3548. Okay. It's saying that equal sum grid partition 2. Okay. Equal sum grid partition, right? We have to find, right? Equal sum grid partition. So if you'll do the grid partition, right, the equal sum should come, and this is the version of part 2. So part 1 I have already solved. You can go through and you can understand that. Okay, so this is the very beginning of this question, right, where we'll understand the question and we'll try to understand what the question is saying that, and how we'll approach this, right? What are the concepts behind this problem, what is the intuition is there, how we can solve this type of problem, right? And in case what is the logic is here, right? And how we are building the logic, those part we will discuss, right? I will try to give you all the insights of this problem, right? So let's try to understand, and if you have any doubts you can ask me in the comment box, and you can reach out to the given the comment section. You are right, you will get the link in the description of this video. You will get the links of WhatsApp. You can reach out to me, you can join our online classes, and in case you are also struggling with the development, right, the full stack development, or either the fang preparation, right, you can reach out to me and you can join our online classes so that we can discuss on the WhatsApp. But let's continue to understand how we can solve this problem and what the question is saying that. Okay, so let's try to understand from here. The very first we have given a matrix called grid. As you can see here, we have given a grid. It is saying that your task is to determine if it's possible to make either one horizontal or vertical cut. So we know that we have to create a vertical. This is a grid, right? So either you can cut this either through the horizontal or the vertical lines, right? So this is what the question is saying. Okay, now try to understand that what the question is saying. Okay, so on the given grid, right, either you can do is you can each of the two resulting sector formed by the cut is non-empty, right? You know that if the horizontal cut we will do, right, or the vertical cut will do over this, right? Let's suppose we'll cut from here. So this part is not empty and this part is not empty. It should have some element. That is why it is saying that the two resulting section means either this section we are talking about or this section we are talking about, right? By cut is non-empty, it should not be an empty, right? Another question, another topic is another point is saying that the sum of the element in both section is equal. If I will do the sum of these two combination, right? So let's suppose call sum 1 and these two will do the sum, right? Then the sum 2. So sum 1 equal to sum 2 should be there, right? And can be make equal by discounting at most one. Means there is a possibility that you can discard one of this cell to make this equal. If the cell is discounted, the rest of the section must be remain connected. Okay, if that is the case, if it is the case, we will return true. Otherwise, if the partition exists, right, otherwise we'll return false in partition not exist. So let's try to understand further ahead and try to understand how the question, what the question is saying that. Okay, so this is our constant we have given, guys, right? We have given this constant. I will try to understand. So we have seen this question, what the question is saying that this is the constant we have given, right? So we'll try to understand what the question is saying that. Let's suppose that we have given this problem, right? Problem understanding is very important, guys. So what we have given a grid of positive numbers, and we want to make exactly one straight cut, right? Either it is horizontal or vertical, right? Then it is saying that split the grid into two halves. We know that we have to split into two halves. Either it is let's suppose the grid is like this, so you can cut either by horizontal or vertical, you can cut, right? Then it is saying that the grid can we make two halves sum equal, right? If we are allowed, means we are allowed to delete one, means we are allowed one small cheat. That is, the cheat is that we can optionally discard one cell, right, from one half, not from both half, one half. Okay, so reduce the half by their cell value, but if we discarded a cell, right, the rest of the half must be connected. Okay, so it is saying that this connectivity rule, what is the connectivity rule is here, right? So after discarding a cell, every remaining cell in the half must be reachable from every other remaining cell by moving up, down, right, left. That should be the possibility. This means we can only discard a cell that sits on the border or edge of its section, and otherwise removing it would create a disconnectivity island, right? Means what trying to say that, let's suppose there is many elements are there, okay, like this. Okay, so let's suppose that one of these cell, if you want to discard, you cannot discard from here, right? You cannot discard. So you have to think that we will corner one we will discard, or this and this corner will discard. So it should be reachable to each other. Okay, this is what the question is saying that. Okay, I hope you understanding. क्वेश्चन बहुत इंपॉर्टेंट है. क्वेश्चन क्या कह रहा है? क्वेश्चन ये कह रहा है कि हमारे पास क्या है, एक ग्रिड दिया हुआ है, उसको आप वर्टिकली उसको कट कर सकते हो या हॉरिजॉन्टली कट कर सकते हो, राइट? दोनों में से एक ऑप्शन है आपके पास. अगर आप क्रिएट कर रहे हो, राइट, अगर आप सम निकाल रहे हो, सम इक्वल नहीं आ रहा है, तो आप क्या कर सकते हो, उनमें से किसी एक सेल को डिलीट कर सकते हो. कोई भी जो सेल दिया हुआ है उसमें से आप डिलीट कर सकते हो. डिलीट करने के बाद उसका जो क्या कहते हैं कि सम है, अगर इक्वल आता है तो हम रिटर्न करेंगे ट्रू, अदरवाइज रिटर्न करेंगे फॉल, कि हम लोग इसको क्या कहते हैं कट नहीं कर सकते, राइट? बट एक और इसमें रूल है, कनेक्टिविटी रूल्स, विच इज़ वेरी इंपॉर्टेंट, कि आप इस जगह पे कटिंग करें, इस सेल्स को डिस्कार्ड करें, ताकि बाकी सेल्स एक दूसरे से रिचेबल हो, राइट? दिस इज व्हाट द क्वेश्चन सेइंग, राइट? आई होप यू अंडरस्टैंडिंग. अगर कोई डाउट हो, यू कैन आस्क मी इन द कमेंट बॉक्स. Now let's think that what the question is saying that. The question is saying that we have 3548 equal sum grid partition 2. So we will return when the sum are already equal. So removing one border cell from the either half makes them equal, right? हम कब रिटर्न करना है, right? We will return true when the sum are already equal. इधर यहीं पे हम रिटर्न कर देंगे. अगर ऐसा नहीं होता है कि यहाँ पे सम इक्वल नहीं हो रहा है, राइट, तो हम लोग क्या करेंगे, रिमूव वन बॉर्डर सेल फ्रॉम आइदर और इधर द हाफ मेक्स देम इक्वल. चाहे इधर से लेना है, चाहे इधर से लेना है, दोनों पार्ट में से किस साइड से लेना है, राइट? इधर हाफ, राइट? अगर आप हॉरिजॉन्टली कट करते हैं तो इधर से लेना है या इधर से लेना है. तो कोई एक बॉर्डर सेल्स को आप रिमूव कर सकते हो, बॉर्डर सेल, राइट, ताकि बाकी सब रीचेबल रहे. की कंस्टेंट क्या है? व्हाट इज द की कंस्टेंट? की कंस्टेंट इज सेइंग दैट एट मोस्ट वन सेल discarded total, means discarded cell must maintain connectivity, okay, and both section must be non empty. ऐसा नहीं कि आपने कहा कि मैंने डिस्कार्ड किया है, राइट, लेट्स सपोज लाइक दिस, ओके, हमने यहाँ से डिस्कार्ड किया है, राइट, ऐसा नहीं हो सकता, ठीक है? तो एग्जांपल समझते हैं where no discard is required. Okay, let's suppose we have given a grid where we have element is 1, 4, 2 and 3, right? This is the cell value we have given, okay, and this grid is look like this, okay? Can we say that? So let's suppose that I want to do horizontal cut, right? So how will you do the horizontal cut? We know that this is the horizontal cut we have to do, right? So if you want to do the horizontal cut at row 0, it means that if I want to find the sum of this element, so you will get the sum, top element sum will happen what? 1 plus 4 is 5, and bottom sum if we'll do, it will also be 2 plus 3 is 5, means both are equal, means ये और ये equal हो गया, right? It means हम क्या रिटर्न करेंगे? ट्रू रिटर्न करेंगे, मतलब हमें डिस्कार्ड नहीं करना पड़ा, right? Nothing we have to discard, but both after the horizontal cut we are getting equal sum from the top and the bottom, right? And so the sums are coming equal, and so that is why we are returning true. समझ में आ रहा है ना? इजी है, इतना टफ नहीं है, okay? Now think case 2, right? Example 2 we can say where discard is needed. Let's suppose this is the thing we have given, okay? Sorry, I have not updated this. So let's suppose you have a grid 3, 3, 4, 4, we have 4, 1 we have given, okay? So what we can do is, let's suppose that if I'll do the cut, horizontally cut we will do here, right? 3 and 3 we know that we'll get 6, and 4 and 1 will get the value is how much? 4 and 1 is 5, right? So row 5. So there is a difference. What is the difference is there? 1 is a difference. So there will be no match, correct? Means what we need to do, we have to discard a border cell 4, right? So if I'll say, okay, let me discard it. So let's suppose I'm discarding this 4, right? So bottom left is 1 and top is 6. Still we are not getting equal. So no need to discard to the balance. Okay. Okay, let's suppose case number 3, where we have the vertical cut. Okay, so this is what we have given: grid 1 2 3 4 5 6. If we will do the vertical cut at like this, right, it means we will have first half like this, and this is our second half, right? Like this we can say. If you'll do the sum, so this left will give you the 12 and this will give you 9. If you'll find the difference, we are getting 3. So let's suppose that is the border cell of the left selection, right? So this is your left selection and this is your right selection, guys. Okay, so is 3 a border cell of left selections? No, right? So we'll check. The top left is 1, bottom left is 4, column edges are 2 5 1 4, right? So the value 3 is in the right section of the board, right? So actually it is here, it is not here, right, in this side. So what is saying that, so discard is 9 plus 3, means if we'll do the 9 plus 3, we are getting 12, right? So wait, discard from the larger side, right? If we'll do, that is 3, is 3 in the left border? No, right? So it is not possible. Now check for the vertical cut for the column, how we should see. These two sum is there, left sum and the right sum in the vertical case, right? If we'll do the cutting from the vertical, so the difference will come the left sum minus the right sum, you will get some difference. Now what you need to do, if the difference is greater than 0, right, means need to remove a cell value that is called different, right? Cell value kitna hoga, jitna difference nikal ke aayega, right? The same value from the left section, right? We have 2 section is there, 1 section is here and 1 section is here, right? तो अगर जो डिफरेंस है अगर ग्रेटर देन 0 होता है तो क्या कहते हैं कि जो डिफरेंस आ रहा है वो यहाँ से डिलीट करना है, राइट? दैट कीप द कनेक्टिविटी बॉर्डर. अगर किसी जगह पे चलिए सपोज यहाँ पे से हम डिलीट कर दिए एक सेल में से, बहुत सारे सेल्स इसमें दे रखे हैं, इसमें से डिलीट कर देते बॉर्डर सेल्स, राइट? तो हमें इस वाले लेफ्ट से रिमूव करना है, नॉट कि राइट से में डिलीट करना है, ठीक है? इफ द डिफरेंस इज लेस देन 0, सो यू विल डू व्हाट, रिमूव, हमें करना है रिमूव द डिफरेंस फ्रॉम द राइट सिलेक्शन, अगर लेस देन 0 है तो, ठीक है? नाउ एग्जाम्पल 4 समझते हैं, जहाँ पे रिटर्न करेगा फॉल्स. सो इफ द ग्रिड इज 1 2 3 4, सो नो वैलिड कट एग्जिस्ट, सो विल रिटर्न फॉल्स. वाई? बिकॉज वी ट्राई एच कट, राइट, at row 0. Okay, so horizontal cut will do, right? So we need the sum is 3 and 7 is there, so difference is 4. So border cell value we have 1 2 and neither is 4, right? Similarly for 3 and 4, so here we have these cells. So what we will do, we'll discard this one because this is 4, right? So if we'll discard this 4, now check above is 1 2 and here is 1 2 is 3. Now it is 3, so it is equal, right? So both are equal, so we'll say wait, this is actually returns true. Okay, so we'll say it's returns true, not it returns in the false, because we have done what, we have discarded these cells and now it's equal to the sum. So this type of things we have to discard, means all the thing that we have given is fulfilled by now, right? So real false cases, you can try, you can pause this and you can go through this. I have already written everything. Okay, let me continue ahead. Now it's time to understand the intuition, guys. Intuition is very important to understand the approach, right? So let's try to understand what is the core insight is here. So for any cut, right, you have to compute the top sum and the bottom sum, right? So their difference will get how? Top sum minus bottom sum must be eliminated by removing at most one cell, right? We can remove one cell and then we can find the difference. So a cell can be removed only if it's on the cut adjacent edge of its selection, right, section. Otherwise the rest would be discontinued, right? So we'll compute the total sum by iterate over the grid. We'll check the total, means sum of all the cells. This gives you m cross n, right? So then we will try all the 4 scans, like transformations. Instead of writing the 4 loops, we will reuse this, right? Can we say that can partition grid, and we'll keep doing that checking. So very first we have the original grid we have, so we'll check edge cuts on the top to bottom, right? Then we'll go do the reverse row, right? We'll check the horizontal checks will do cut, and then we'll check. So top horizontal to top will go, and we'll find the catches is cells at the bottom boundaries, right? and then we transpose that. We'll check, okay, after the transpose, what is the coming from left to right, right? And the reverse means all these are the checks we can say that we will do, right? Means we are trying to say that we are trying all four direction via the transformation, and these are the transformation: original, reverse, transpose, and the reverse and transpose. So these are the four things that we should try, right? So let's suppose that if we'll check in, like we are getting the can partitions, right? So we'll try to sweep row by row and we'll accumulate the top sum, right? And at each cut, let's suppose call position I, we'll check the bottom sum, means total will get minus total sum will say, and then we'll check the difference, means top sum minus bottom sum will do. Each time what we'll keep checking is the difference. Check if the difference can be resolved. It's if difference is 0, already equal. Difference is coming grid at 0 0 means first cell of the first row always corner always removable, right? Then we'll check the difference grid at 0 and last means the last cell which is corner one, right? Similarly we'll call for the grid this one, right? Means first cell row a cell. Then we'll check the difference like this and we'll say okay, any previous cell value that have equals, as long as we are not in the single column degenerate case, this will be this. Like these are the checks that you have to follow. That I hope you understand. You pause this and try to read that, you will understand. So we will maintain a scene hash set, right? And then we'll encounter in the row scan so far. So all those cells are on the top side boundaries. Cut will do. So we'll check if the difference matches with any scene. So that cells will be discarded. The half balance. Why these four directions we needed? Because the connectivity rules means the removal cell must sit on the cut boundary. So we'll do the sweeping, means top to bottom with the scene catches, right? So cells on the top, cells bottom edges, we'll do the sweeping from the bottom to top. Like that we'll keep checking all those and we'll handle all the boundary conditions that without doing that. So in case if you'll use this approach, it is very optimal, because as per the constraint it's working fine for all the things, right? So each cells visited a constant number with all the first scan. Then we'll do the transform and reverse. In that case we have to maintain, so it will taking O of m cross n, right? By using the HashSet also. So the approach is called prefix sum. Will use prefix sum and HashSet will do the four sweeps, right? So we already understood how to do that, right? Let's try to understand the code, right? The very first you have given the grid, right? Let me check with this one. So we have given this grid, right? So we have a sum, right? So we'll do the flat map to int. Over this you will find the sum. This is Java 8 concept where you can find the sum, means total grid cells will be calculated like this: arrays dot string, we will pass the grid, so you have converted into a string. Then we will do the flat map to int arrays string. So you basically from map to int you will do, and you will check the long string, and you have converted in the long string, and you will calculate the sum. So finally we'll return the long sum. Okay, basically we need to do the four scan like this. We'll try to do. Okay, so grid sum, reverse, transpose, reverse, transpose. So these helper functions will calculate, and we'll check if we'll do the partitions, right? If it works fine, means all the having the sum is equal, then we'll return true, means all the cases should return true. Let's suppose the very first can partition, we have a grid, right, and the sum. So the very first helper function will calculate the sum, and means for the partition part, right? There will be a scene HashSet, will calculate the top sum, right? We know how to calculate stream grid as long stream, will do the sum and will calculate. Then we'll have the bottom sum and the difference. So sum minus, we have already calculated the sum, so top sum will do sum minus top sum, you will get the bottom sum, and then you will find the difference, right? Then arrays dot string will do, and over each cells we can iterate, right? So we'll keep adding on the scene. Basically scene we are doing the add, means over this scene we are adding that this cell is getting added, means grid at I is getting added on the where, on the HashSet, right? Once this is done, so we'll calculate if the difference comes 0, means the bottom and the top both are same, right? If you see here, the difference we are getting from top sum minus bottom sum, so difference is 2, means the partition we have done, let's suppose for this case. So this two are top sum, this is a top sum, and this is the bottom sum, right? So we'll get the equal, so we'll return true. Then we have difference is equal to the grid, so we'll say okay, we'll return true in this case also, because this is difference is matching with the very first grid, right? Very first cell of the grid. Then we'll check the difference is equal to like this, means the last cell, we can say the corner one, so it's also true, we can delete that one. If difference is equal to grid IO, means we can also delete this one. So all these cases, if the difference is either 0 or is equal to the corner cells, will return true. This is the very good concept, because if we will not follow this one, so it will, and obviously will give you the error. Means to avoid the large avoid the overflow, right, you should do the guarding of the casting values, we can say that, or you can say that casting to the int value. So grid at I will check if it greater than 1 or I greater than 0, will check the difference greater than equal to 1, difference is less than equal to 1000, 10,000, approximately lakh, not 10,000, lakh, based on the constant. So we'll keep checking that, and we'll keep adding if it is on the scene, so we'll keep checking that the difference, and then we'll return true, otherwise return false. So this is a simple case where we have to typecast, right? Now let's suppose the transpose things, right? So we will get the res, right? So we will calculate like this, like the grid at 0 dot length and grid at length, means we will create the res, right? So what this transpose will do is transpose the array matrix, and will return it back, right? Because return type is this one. That is why we have to create first the transpose matrix, right? And after the transpose, you know that the ji will contain grid ij, correct? Only we have to, the row will go to the column will go to the row, and will return true. Similarly for the reverse cases, that we'll do a stream dot collect collecting, and then we'll do where we have we'll convert into the list, and we'll do the reverse. So this is a reverse, you can use the Java 8, you can directly do the reverse. So I'm using this Java util stream collection, you can import directly, you can directly use the collector dot collecting, and similarly for the collectors dot to list, and you can do that. So the list is getting reverse this time, and we are appending, we are converting into the array back to the return. So reverse array will get here. So all these cases are done, guys. So basically, if you see here, so we have created this function can partitions, and we have passed the original grid, then reverse grid, then transpose grid, and then we have reverse of the transpose grid. All these four selection will do, and each cases we are checking the the partition will happen or not, or mostly this is the main function where we do all the logic, and here we are checking the difference, right? So in case if you still have any doubt, don't hesitate to write the comment, right? And I don't think that you will hesitate, right? You can reach out to me also directly on the WhatsApp, and you can ask me here there also. But still, if you have any likely question, you can ask in the comment section, so other can also get the answer there. Thank you so much for watching this video. In case you are a new at ExpertFunda, please give a thumbs up, and like, share, subscribe, and please share this video with your friends if they are doing really preparation, and create your own environment to crack the FANG interviews and the product-based company. In case you are struggling with that, you can join my online classes, and you can do the preparation based on goals, and you can set your goals to crack the interview. Thank you so much, and I'll see you in the next one. Bye bye.